The good news is that we're not going to die of asphyxiation because it would take hundreds of years to use up the oxygen in the atmosphere. The bad news is that we're going to die of hunger, and much more quickly, because if they go on an oxygen strike, they won't produce any more food.
Yeah.
So the good news is that we won't die of asphyxiation. The bad news is that we'll die of hunger.
Yeah, it's not necessarily the best option.
All right, so we need to give some sense of time frames. But today, telling people about these long time frames, and then saying, for example, in about 3,000 years, there will be 120 meters of water over Paris. It makes you think a bit. You could say, in 3,000 years, the number of stupid things we could do, we've got time. But we still need to remind people, and that's the importance of biodiversity. It's about making them see they're just brief, insignificant creatures who, in life's scale, exist for only a moment. And since we're supposed to be intelligent beings, we should put ourselves in this perspective. What are we doing to pass things on to those who will come after us? To make sure they have living conditions as good as ours or better in many places in the world? That's also what we're trying to say when we talk about biodiversity.
So, to get back to those organisms in the ocean that capture CO2 to make a shell. So, obviously it creates a self-amplifying effect, because if CO2 causes the greenhouse effect and therefore contributes to warming, and the heat of the oceans contributes to the acidification of the oceans, and therefore prevents these organisms from being able to capture more CO2, does that mean that the effect produced by CO2 will amplify itself over time?
Yes, you understood the problem perfectly. Today we estimate that all this carbon dioxide, which is absorbed by some forests, the ocean and so on, saves us about between a third and half of the greenhouse effect, meaning it absorbs about a third of all the carbon dioxide we emit. So they buy us time, they slow things down, precisely because all the carbon dioxide we emit, they take some of it back. But if they start to go on strike, like I was telling you, then all the CO2 we emit, well, it won't be absorbed anymore. Even if we say, well, we'll pump it, we'll put it in oil fields and so on. But today it's still not on the scale of the problem, and so that's the issue. And for example, you know that there's a lot of talk about 4 degrees of warming by the year 2100. We don't say enough that if we reach 4 degrees in 2100, it means we haven't solved the problem. In other words, we'll stay on an upward trajectory. And based on that, we can calculate that if we were idiots, which can happen, and we decided to say, we don't care about renewable energy and all that, we're going to keep burning all our gas, all our oil, and all our coal, meaning we're going to use up all the fossil fuel reserves. And we know that, for example, with coal, we can keep burning it for another 200 or 300 years. So there's too much coal. Well, there's more than enough. It's not 4 degrees, it's 11 degrees. And with 11 degrees, it's impossible to know what could happen. It's absolute horror. So the challenge we have is how we're going to be smart enough to do without something that will still be abundant and cheap. And look at what's happening in the United States. The temptation to dismiss electric cars and renewable energy as nonsense and just use the cheapest energy sources. Well, and you may have heard that we've discovered, or at least we think we've discovered, a huge gas field under the Mediterranean, off the French coast. And if we stick with that by saying we keep using the cheapest energy and it will stay cheap. You have to realize that if you look at the last 20 years, electricity, the price of electricity has increased faster than the price of oil. That's a huge challenge.
All right.
So you might say that we managed to do without resources that were still abundant and cheap when we stopped using flint tools. After all, there's still a lot of flint left. And yet at some point in history, but it wasn't due to negative effects from flint, was it? It was because we invented metallurgy and decided it was more practical to move on to the Bronze Age and the Iron Age. So sometimes we can go without something even when it's still abundant.
If we have something better.
If we have something better.
So, to go along with this theme, do we have any concrete solutions today to avoid having too negative an impact on our environment? Or is it still pretty hypothetical for now?
Well, you really have to look at it on a case-by-case basis, meaning you have to say, we know what the factors responsible for biodiversity loss are, but from one species to another, those factors will be different. There are species where all you have to do is leave them alone, meaning if we stop exploiting them, they can recover more or less quickly, depending on the biology of the species. I'll give you two examples. The beaver, which was an extremely abundant species throughout Europe in the Middle Ages. By the end of the 19th century, there were only a handful left in the Rhone Delta. There were none left anywhere in France. France has many places named Bièvre, which shares its etymology with the English word beaver. So those were places where there were beavers everywhere. In 1909, they simply banned beaver hunting. It was an animal that had a lot of flaws. You could eat it during Lent because the church considered it a fish. It had very warm fur, like Davy Crockett's hat, which wasn't made of beaver, but still, it was that kind of thing. And above all, it had secretions that were considered aphrodisiacs. So people hunted beaver, really. It was a source of food. In 1909, they said, no more hunting beaver. Our good old beaver made its way back up the entire Rhone Valley via the Saône. After relocations, beavers are now widespread in France and their numbers started rising again. The other example is whales. Whales came very close to extinction. And apart from the Japanese and a bit the Icelanders, we've managed to limit it a lot. Well, they are coming back too. So there are species where we know that if we just stop over-exploiting them, then it's fine. Then there are species that are exposed to pollution, where it can be, for example, for birds of prey, we know they are very sensitive to pesticides. Why? Well, because a bird of prey eats other animals that themselves eat plants. So you see, if we treat plants with chemicals, it will accumulate. So those at the end of the chain, what we call the food chain, well, they will accumulate, and so they will have particularly high concentrations. And we realized that in addition to our problem with limestone, it was also blocking the fixation of carbon in the eggshells. It made the eggs soft. And today we hear a lot about endocrine disruptors, forever pollutants and so on, epiphytes, etc. Actually, we realized it because some species living in the wild told us, oh, there's a little problem. Maybe you should examine what's happening to us. Just like we saw fish that were becoming both male and female, because there were also disruptors affecting their reproduction. And indeed, we can clearly see that there are species very likely that are being wiped out, especially because of pesticides in particular. It can be some rather silly types of pollution. I'll give an example from Brittany. You know that Brittany is a very beautiful region, and there are still salmon that swim up the rivers. And the salmon swims up the rivers not for the pleasure of swimming upstream, but because it needs fairly cool water, and especially a place where there are large gravel stones on the riverbed. Because that way it lays its eggs, the eggs settle between the stones, and since they're large stones, the water passes through them and brings oxygen to the eggs. They can develop. If in the watershed you start growing corn and it rains during the winter, it causes soil to wash down into the river. Well, that's going to clog up the bed of stones. So the water itself stays clear, it's not polluted, but the eggs that end up covered with clay die.
They suffocate.
So we don't see salmon carcasses on the surface, we don't see massive die-offs. But small signals like this, which we aren't sensitive to, well, can be enough to disturb a species and even cause it to disappear. Here's another somewhat silly example. You know that many insects, the males, to attract females, emit substances that are detected. The ears of insects are their antennae. So these molecules are detected by the females, and the females will go toward the male, right? In cities, ground level ozone is common. That's why you shouldn't use strollers that are too low for babies. Anyway, now ozone is an oxidant. It's something that destroys organic molecules and will destroy these olfactory signals. It's like someone cutting your fiber optic cable to the internet.
All right.
So the female is searching.
And she can't find him.
So you really have to understand that all these living beings, well, to live, they're just like us. They need to communicate with each other, to exchange sound signals. For example, you know that city birds sing a bit higher than country birds so they can be heard better, since there's a lot of low frequency noise. So they adapt a bit. But they need to emit sound signals, possibly magnetic signals, chemical signals, to communicate with each other and to recognize each other. So we really need to be careful about the fact that we're big creatures and we can easily disrupt this whole internet of living being because we can't sense these substances and there are lots of sounds we can't hear. For example, a cow can hear frequencies that are about twice as high as what we can hear. In fact, at my age, it's even 4 times higher. As we age, we can't hear high-pitched sounds as well. So the cow will hear things that we can't, which can alert her and possibly disturb her. Likewise, you know whales, in contrast, hear extremely low frequencies. So all this signaling, all this network of messages that living beings exchange with each other, they need it. And we have to tell ourselves that we shouldn't be like a bull in a china shop, you know?
Yeah, but it's true that it's pretty complicated because when I hear that, I feel like no matter what we try to do, we inevitably have an impact on living being, whether it's on things that seem obvious and that we can have an impact on. But sometimes there are things that are much more subtle, things we don't necessarily realize. So how can we control the impact we have?
Well, if you want, there are species that really need us to leave them alone, really, completely. I'll take the example of the capercaillie. The capercaillie is this kind of huge grouse that hibernates under the snow in the mountain ranges where there's snow. And it stays at a slightly lower temperature under the snow all winter. If someone goes off trail hiking and disturbs a capercaillie while it's hibernating, the capercaillie will start flying. So, first it has to warm up, and it's said that if it's disturbed just twice during the winter, it won't be able to survive. It's the same thing for bats. You know, bats hibernate in caves. If you accidentally enter a cave where there are bats, it's going to be a huge panic. And by the time they settle back down, they will have used up some of their reserves. These little creatures don't have a lot of reserves. So there really are species for which we need to find completely protected areas, where we tell humans, sorry, but here you have to go very quietly and in small numbers. And that's what we call a strict reserve. Then there are other species that don't need that much. So that's what I was telling you at the beginning. You have to do things tailor-made, meaning you need to know what the requirements are. I like to say habits, because often people say species have requirements. No, but they have minimum needs, that's all. And then actually see which ones just need us to stop exploiting them and others that might need more significant protection.
Especially since we are in fact part of this ecosystem. Of course, we have a huge impact on the life around us, but the life around us also has an impact on our own lives. Earlier, we said that we shouldn't necessarily classify species based on the interest they have, especially since very often when we judge the importance of a species, we judge it based on how useful it is to us. But there are a huge number of species that provide us with incredibly valuable services and actually allow us to live. Do we have examples of these species that we depend on?
I gave you the example of those species that alert us. What we say biodiversity is humanity's life insurance. In other words, these are species that we can consider as warning givers in a certain way. And there are species that function, for example, by producing oxygen. But there are others that, for example, will remove excess pesticides or excess nitrates from the water. That means we don't need to build water treatment plants. There's an example that's always mentioned, which is the city of New York, which had to choose, in order to supply New York City with drinking water, between building water treatment plants or redeveloping the entire watershed to have very low polluting agriculture. They calculated treatment plants would cost 10 billion, while redeveloping the watershed would cost 2 billion, saving 8 billion by using the ability of biodiversity to naturally purify water. And then there are cases where by imitating living beings and the know-how of nature, we find solutions to problems. I'll take an example that you may have experienced, which is during COVID, to find out whether you had the disease or not. They did a little unpleasant thing by swabbing your nose, and they told you, we're going to do a PCR test. Huh? Maybe you remember? So what's this about? Well, more than 50 years ago, there was an American biologist, back when American scientists could do whatever they wanted, who thought, hey, in the geysers of Yellowstone, in Yellowstone National Park, where the water is 70 degrees, is there life in that water? He looked and saw things resembling bacteria. And then he said, well, yes, but are they really alive? And he showed that they reproduced at 70 degrees. Reproducing at 70 degrees means they were able to multiply their genetic material, their DNA, at 70 degrees. He examined how it worked and then asked, what if I take a small piece of DNA from the nose? Because when they scraped your nose, there could have been 5 or 6 viruses. And so if we can extract all that, this little piece of DNA, and then multiply it very quickly with what it does to these bacteria, we have enough DNA to say, yes, it's actually the DNA of COVID, or it's not the DNA of COVID. So this crucial result from over 50 years ago, thank goodness we had it to actually be able to very quickly diagnose people who had COVID or not. So there is, if you will, a whole range of know-how from living beings that we're glad to find, often long after. Let me give you an example that I like. You know the carrot, right? Well, we thought we knew everything about the carrot, really. There was a chemist quite some time ago who extracted from the carrot a strange molecule that he crystallized. Now, I'll spare you the name. It's a real tongue twister. But he crystallized it and noticed that it changed color with temperature. He said, well, that's interesting. That's how the first liquid crystal displays were made. That was the discovery of liquid crystals, meaning those crystals, whose display changes when you apply a little resistance. And it was a carrot that could also make liquid crystals, and we discovered that a long time after. I could give you plenty of other examples where, to sum up, it means that living beings are like a huge library of books, of things that living beings know how to do, and we've only read a tiny part of it. And that means when we ask the question, should we keep all these species? That's what you were saying earlier. Well, the answer is, as long as we haven't read the books, maybe it's better to keep them.
Yeah, to get back to some species that are sometimes a bit unusual. Are there any examples in living things that have struck you, that maybe surprised you, that you didn't expect?
Sometimes we wonder how such species managed to survive until today. I'll take an example, which is what we commonly call the cousin, that is, this long-legged mosquito that's clumsy. Unbelievably clumsy, always getting stuck on the smallest dust or webs. The scientific name is a cranefly. It's not harmful at all. It doesn't sting. But I said, but how did this creature even make it to us? In other words, for 3 billion years, living beings have been constantly reinventing themselves. Since we've never seen a species that disappeared come back, it's other species that appear. But none of them has found the definitive solution. In other words, they all found ways to exist for varying lengths of time. And then constantly they create new things, and that's what's amazing and maybe should inspire us a little. It's that, rather than saying we're going to find the ultimate solution to all our problems. Well, saying that all living beings and therefore all humans might have solutions to offer for tomorrow's problems, maybe that's what it teaches us. That is a certain humility in saying, well, you shouldn't dream about yourself alone having the brilliant solution. We have to say that collectively we're trying to adapt, to invent, and so on. Because one of the recent things in biology, you know that now that we can look at what's called the genome, that is the genetic material, we can calculate, for example, for humans, how many different possible human beings there are. We can say, knowing what we know about the genome, that there are billions upon billions upon billions upon billions of different possible human beings, which means that two living beings, we will never have two identical living beings. That is, with each generation, living beings, they don't reproduce, they renew themselves. Reproduction would mean even twins aren't truly identical genetically. Living beings continually renew themselves, trying small changes to see what works and what doesn't. When the environment changes, what was once valid may no longer be. And it's a kind of extraordinary mechanism that's been going on for 3 billion years, constantly reinventing itself with entities that don't last very long. You have to remember that most living beings live less than a year, weigh less than a gram, and move less than a meter during their lifetime. So we're very specific. So these little things that last just a moment, that's what makes up life, which has been constantly renewing itself for 3 billion years.
We saw all the life teeming around us, but from what I understand, life is also teeming inside us. We also talk about the microbiome and about different species that are even in our mucous membranes and on our skin. Do all these species interact with us? Are they part of us? Or should we really see them as entities that are separate from us?
It depends on how you want to think about yourself. That is, you have the information, you just gave it. That is on the surface of our skin, in our eyelashes, in our mouth, inside our digestive tract. Well, there are lots of other living beings, and we know that they are very diverse, even genetically. If they are there, it's because they find it beneficial. In other words, we help feed them, but in return, they protect us. For example, you don't ask yourself, is my brain a part of me? Yet you know very well that your brain sometimes does things without asking for your opinion.
Yeah.
But you don't blame it. You say, it's still me, even if sometimes it plays tricks on you. For example, one extraordinary thing is the number of things your brain decides to remember that are absolutely useless. Think, you probably remember, for instance, your first scooter's license plate number, or whatever. Basically, information that the brain decided to keep, which is useless. Then, there are things you want to remember, and your brain doesn't want to keep them. So it does its own little thing in its corner, but it's still a part of you. And indeed, that's the question, this flora that lives with us in harmony, that protects us. Do you handle it by saying, it's part of me? Just like you take care of your muscles, your heart, etc. Do you say, it's an organ that belongs to me? Or do you say, well, those ones, I keep them because I can't do otherwise. Unless I constantly take antibiotics, which wouldn't work very well, you'd quickly see the problem.